So the goal now is to present some classes, two classes actually, one for a person and one for a vehicle. And these classes are geared towards managing a road trip. So managing the fuel consumption and things like that, and who is in the car, who has gone from the car, etc. So to do this, I have three files. So you see four here, but I really have three, the PY files. So one for person, one for vehicle, and the main file for the road trip itself. So let's look first at the person file, but it's important to understand that it's organized so the functionality is very separate and very localized. So I will first introduce the person file, which contains the person class, and I will introduce it without on its own, not in relation with the others. So if you look, this is the content of that file, and you see that it consists of just one big class definition. There is first a bit of documentation, so what this does, and so this is essentially what I just said about the organization of the code. And then there is this class person. So if I do from person import person, I'm now in the interpreter, and I can use that class person as I wish. So you see that this class already has a different naming convention because it has a capital. It's capitalized. So that's intentional. And the goal is that you can distinguish easily between classes and instances of a class. So let's call the constructor of person. So, and this init function here with double underscore with different arguments. And so I have to enter a first name. So that would be Paul, and a last name, Dehaye, and some sex. So I'm male, so that's why there is an M. And then some weight, and I'm afraid I'm more than 70 kilos. So this would be the way to call the constructor of a person. So now you see that I have constructed here an object of type person.person. So this is pointing back to the class definition here. And this is the location of that object in memory. Now, Python can do, and if I create a new, if I run it again, I get this object. So if I want to print that, then Python will use the str function that is defined here to print something. So you see how the interaction works. I have my object, and that is created. Maybe I save it to a variable name. So now I use underscores to distinguish because this is an instance now. So I have an object Paul, and I can look at it and I can print it. When I print Paul, I get Mr. Paul Dehaye. I also can call different attributes or different methods. So in this case, it would be full name would be a method. So you see that this returns Paul Dehaye, and full title gives me my name with a title. So those are method attributes, full name and full title. We've learned to recognize them. There's also different kind of data attributes. So for instance, the weight, and you see that my weight is 80. What's important to notice here is that it's 80 as a float, while the argument I passed to the constructor here was an int. So some conversion happened. So this is how you interact on the right with this class. And let's see how it actually happens here. So how is the class defined? Well, it has a class, and the keyword class, and then the class name, person with a capital, and then the objects it the classes it inherits from. And I told you if it doesn't inherit from anything, you should just put object there, and then a colon. And then it first has a docstring for the whole class, and this is here a one-liner, a class representing a person in the context of a road trip. And it's in the context of a road trip because it will keep data about the person that's useful to manage a road trip. So what are the different methods? So we saw them. There is the constructor init, there is full name, there is full title, and there is str. the arguments that you pass to the constructor are first name, last name, sex, has license, which is a keyword argument, so optional, consumption factor, and weight. And then there's the docstring explaining this, and the consumption factor is here a float, is here converted to a float, and the documentation says that this is the ratio of gas consumption to average driving. So if you're a nervous driver, this would be 1.5. If you're a calm driver, this would be 0.8 or something like that. So you see that the constructor, what does it do? Well, it takes self and accesses an attribute or defines a new attribute, first name, last name, sex, has license, consumption factor, and takes all those different things. So at this stage, this might not be so surprising, or this might be okay. The next step is actually where things start to get a bit weird. So here I have a first method, so full name, and this is a docstring, and then if self.lastName is defined, then it will return self.firstName plus a space plus the last name, and otherwise it will return self.firstName. So why does it do that? Well, because we don't want to if no last name is specified, for instance, if you define person, Mickey, and then don't specify a last name, then if you print it, we don't want to have an extra space here because it would make things look weird later on. So that's why we do this little distinction. So if last name is an empty string, then this would be false. So this one would be executed instead. Okay, so this is all fine, but there's one weird thing still. And that weird thing is that we have here, we are accessing the full name in this way, and it's defined in that way. So if you look, there's a difference here that this here does not take an attribute, an argument, while this one in the class definition does. And this argument will be self. So how does this work? Well, this works because person.fullName is a method, and so this is exactly this function here, and that guy actually can be run on some object Paul, and this is what will happen. So this is actually not surprising compared to this definition, right? So this is person.fullName, and it does take an argument, some object, some instance of Paul, and then it performs all that. The point is that this is a shortcut that Python constructs for that. Okay, so this guy here is a shortcut for that command. And Python figures out that you have an instance here, you're calling a function or a method on that instance, so it should really go look at the class and call the method defined at that class on the instance Paul. So there's a lot of things here that are kind of magical that Python makes happen in the background, so it's quite simple to, in the end, define methods. Okay, and then full title, well, there's some kind of choice that's made for greeting, so that's kind of simple, and then the full title is returned, and str, which is called by print automatically, will return the full title. Actually, that's a decision I've made. Okay, so now we've seen how to use this simple class, and we could use it for all kind of things, and with little modification we could also contain email or whatever, depending on your eventual goal. But it's nice, it's self-contained, and it deals with persons. Now let's look at the class that deals with vehicles. So the class that deals with vehicle is here. it's in the vehicle.py file, and again there's some documentation, and then there's a bunch of method definitions. So let's do the same thing here. So from vehicle import vehicle, okay, and let's define a new vehicle according to the conditions here. So I will have like my car, which would be vehicle, and well, it only takes optional arguments, so the model would be like, okay, let's go crazy, a Ferrari, and it seats 5 people. The weight might be 550 kilos instead of 500 kilos, and the consumption will definitely be higher, so the consumption will be maybe 10 liters per 100 kilometers, and everything else I'm happy with. So this is my car now, and I can again ask the interpreter to tell me what it knows about the object bound to the variable name my car, and that's what it says. And if I ask to print my car, it will tell me a bunch of stuff. Okay, so this Ferrari, which weighs 550 kilos and seats 5 people, has an average consumption of 10 liters per 100 kilometers and a tank of 40 liters. Right now it has 40 liters in that tank and covered 0 kilometers. None is... Okay, so this should say no one is at the wheel and there are no passengers. Okay, so this is the result of calling str on my car. So let's see how this is done. Again, I have different keyword arguments. I assign it to data attributes. I do a little trick here that's called operator switching. So the default argument for tank content is none, and this really means if it's none, that the tank is full. Okay, so you always rent the full tank. So here I do self.tank content equals tank content, and that's fine if it's defined, but if it gives none, then the second part is evaluated, and it's actually the tank capacity that is used. By default, there is no driver, and there is no passenger. And I've decided, this is a decision I've made, to store passengers as a list. So I have here to initialize this list to be empty. Okay, so I've made several decisions actually. I've decided to keep the weight afloat, the consumption afloat, covered, also the number of covered kilometers as afloat, and the passengers to be an additional list to the driver. Okay, so this is an interesting this way of doing things. Maybe not the best, probably not the best actually. Okay, and then there is str here, and str will do different things depending on what the situation of that instance is. So if there are passengers, then the message associated to passengers should be this. The passengers are, and then list all the passengers. Otherwise, there are no passengers. So you see that this is what was used here. There are no passengers. And the driver message should be the self.driver converted to string or no one. So it should be again the same thing. So, but here I actually made a mistake, so that actually this should say no one is at the wheel, not none is at the wheel. If you think about it, you will see why. And then I return a string here, a long string that I'll format using all the different arguments, passenger message and driver message. And then here I'll use the internal dictionary of self. So this is how you use it. You expand it using the double star, and I pass that to format, which allows me basically to get self.model, self.seat, self.weight, self.consumption easily here. This model, this weight, this seats. So, and this is good for formatting. It makes things a lot simpler. Okay, so these are the basic functions, the basic methods to create the object and to print it. But then you want to do different things with it. So, okay, so this is, I have now my car, and I have defined a take wheel method. And who takes the wheel? Well, Paul takes the wheel. Okay, so Mr. Paul-Olivier is taking the wheel. Now, why is this interesting? Well, it's interesting because you see here that take wheel, the method, will take a new driver, and we'll check that the new driver has a license. Okay, so this here uses what we saw about person, what the information we're keeping about person. So we are accessing here this information. And if there is already a driver in the car, then it will print this person leaves the wheel for this other person. Otherwise, this person is taking the wheel. But again, it has to print new driver. And here the argument I've passed is an object of type person. So it has to print this object of type person. And if you remember string formatting, this means take whatever is after the %, so this new driver, and the S here means convert it to a string, and then print is taking the wheel. So here what is happening is that the string method on the Paul object is called, and that's why Mr. Paul-Olivier shows up. Okay, so this is very important because it shows you the advantage that you can have in dealing with all this. It displays things more. I mean, specifying what you want to display is better, is well done, and just easier to implement. And so this changes the driver, and you can see that. So if now, did I define Mickey before? No, I didn't. So let's take this person. So Mickey is the person, and let's now have my car take wheel Mickey. So again, you see that this executes string on the Mickey object and on the Paul object that was stored in my car, or at least a reference to it. And okay, and you can do all kinds of manipulations like this. I don't mean to show you everything here, but you can see that you could unload, you could load passengers, and then so this is all manipulations with people, and there is no substantial difference with everything I've explained so far. It's the class vehicle is maintaining a list of passengers, and this list will be expanded progressively. So if I now I've seated the wheel to Mickey, so I can Mickey can invite me in. So I'll get in the car, and so I'm getting in the Ferrari, and then my car, I can print my car, and this will start to give me information about who is driving, is at the wheel, and the passenger is Paul-Olivier. Okay, but I can also access some attributes like my car.passengers, and you will see that okay, and this is a data attribute, so it will have it's a list that contains persons, but if I ask to print the first or the only passenger in the car, I get Mr. Paul-Olivier. So I hope this feels more natural, or this feels natural. The advantage of using classes is that you can keep some data and start manipulating it and using it and doing more complicated things. So here I have defined, well, my goal is first to define a new method called loaded weight. So this is the weight of the vehicle, the weight of the passengers, and the weight of the driver all added in. So you see that I can ask for the loaded weight of the car, and this should be, I think, 700, yes, because it was 550 for the car and 150 for Mickey and me. Okay, so, but this is part of the interface, so anyone using the vehicle class can call loaded weight, but you will see here that this also uses the occupant's weight method, And that occupant's weight method gives you first the weight of the passenger, and then the weight of the car is added later. Okay, so the initial underscore is just a convention. It doesn't mean that I can't call it, because I can. Let's see it. So you see here it's 150 for the occupants. It's just a convention indicating that you don't want people from the outside to use this method, because you can't guarantee that in the future that method will be there. Okay, so it's for the person writing the class, but it's not part of the interface. Similarly, consumed here figures out how much gas would be consumed if this distance was covered. So if we took the car together, Mickey and me, with Mickey driving, and we were curious about how much gas we would consume for 100 kilometers, this would be 12.72 liters. And you see that the computation associated to this is quite complex, but it only has to be stored. It only has to be typed once, and then it can be reused all over the place. Okay, so this is again an internal method, not part of the interface, but it will be used when for another function, which is the function drive, which is part of the interface. So my car dot drive, and then 100 kilometers, that drives us for 100 kilometers. But you also see, if you print my car, that this changes things, because it tells you so my car dot drive affects the data attribute. Okay, you see that the tank capacity or the tank content has changed. Now it's only 27 liters instead of the 40 initially. And you see that the mileage, so how many miles or how many kilometers we've covered, is 100. So if we go for another extra little drive with Mickey, and then I print my car, you see that now I have only 26 liters, and we have covered 110 kilometers. So you see that it's important when you manipulate this vehicle object that you keep track of some data from call to call, and this is what the class technique or the object-oriented technique allows you to do. And finally, there's another here method that is refill. So if I wanted to refill the car, I could do it. So I am it doesn't take an argument. It's just I'm refilling. I'm putting it again full. Okay, so this is the whole thing with the vehicle class, and you saw my interaction with the vehicle class. And I have also defined a little script here that basically does similar things with person and vehicle, and this would be road trip. So if I import road trip, a bunch of things will happen. So you see that I define a new persons, John, Paul, Ringo, George, Pete, Frodo, Gandalf, Bond, and Bond Girl. And they have all kinds of parameters associated to them. Then I print John, and this will give me Mr. John Lennon. I will define a new object, a yellow submarine, which sits 4 people, and I'll print information about it. Then I'll drive for 20 kilometers, but this will be refused because the vehicle has no driver. It's not going anywhere. So first Ringo has to take the wheel, and then John being John, John takes over the wheel, then John drives it for 10 kilometers. Then I see the status, so it still weighs 500 kilos, seats 4 people, average consumption this much, but now it has a little bit less gas in the tank. So John will start loading Paul, Ringo, George, and Pete, but sorry Pete, there is no more space, there is no empty passenger seat, okay? And then this will be driven for 200 kilometers, and then another 100,000. I don't think so. There is not enough gas. And then final status of the submarine is that it has covered 210 kilometers, and this is the situation. Similarly, I can define a wooden barge with 20 people in it, and there is basically Gandalf and Frodo, and Gandalf will lead the barge for quite a while. So you see here, And finally, James Bond with his Aston Martin that sits only 2 people, has a very high consumption, little tank capacity, quite some weight. Well, Bond tries taking the wheel, drive for 100 kilometers, but that won't happen because there is not enough gas. And Bond drives like a maniac. But if it's the Bond girl driving, then she's much more gentle, of course, and this being the James Bond movies, and then you can see that she can actually drive for 100 kilometers. Okay, so this was hopefully a fun example of using classes. And the point of going through this whole thing here, which is redoing exactly what you were looking at in my interaction here in the interpreter, is that if you look back, the code is a lot simpler here than it would have been in without object-oriented programming. So you can almost read what's going on directly. You don't have to manipulate heavy data structures. You don't have to do anything fancy. You just use the interface to those objects, like drive, take wheel, and so on, to manipulate them. So it's much better. Also, if later on you realize that you made a mistake and you shouldn't have maintained the passengers list as a list, you can always correct that, and you know exactly where you have to correct something. In particular, you don't have to correct anything here. Okay? You just have to correct it in the vehicle class, and you have to make sure that the interface still works, and that's it. So it helps maintain code, and it helps build much more advanced code later on. So for your projects, I really encourage that you think hard about what the classes should be, how they should be separated, and actually you separate the concerns among you guys according to classes. So one person will take care of vehicle and one person will take care of person. That kind of division is very good, and it helps build good code. But those 2 people still need to talk about the interface. What will I need from vehicle? What kind of actions do I want to do with vehicle? What kind of actions do I want to do with person? Things like that. So the interface involves everyone, but the actual internals, that's specific to the class and could be delegated easily to just one person.